Suppose you have a project in Pygame, but you have a major issue. When you resize the Pygame window, your field of view increases, and you see things that you shouldn't be able to. This Pygame tutorial will cover proportional window resizing. We're going to make it so that when you resize a Pygame window, all elements within will be resized to the same scale. Right now I'm in VS Code, and we'll be using two images for this tutorial. One of them is a Pikachu with a red background, and the other is a black and white grid of pixels. And this is a 10 by 10 image. And just keep that in mind because we will be using this later on. Now let's go ahead and make our main.py. And if you don't already have Pygame installed, you can go to Terminal, New Terminal, and type pip install Pygame. But I do recommend installing the Community Edition of Pygame, Pygame CE. The only modules we'll be needing for today's tutorial are Pygame and sys, so import Pygame sys, and from pygame.locals import all, and we can initialize Pygame, pygame.in. And now let's just make a typical Pygame window that you would make. So window equals pygame.display.set mode to store up here as window mode. Let's just make it 400 by 400 temporarily. Set mode to window mode, and Pygame resizable. We want to be able to resize. And we'll make a main game loop while true. We can call pygame.display.update, and we also want to be able to close our Pygame window. So for events in pygame.event.get, if event.type is exit pygame.quit capitalized, then we want to quit Pygame, pygame.quit and sys.exit. When we run, we have a 400 by 400 resizable Pygame window. We can also set a fixed frame rate of 60, so FPS equals 60, and make a new Pygame clock object, clock equals pygame.time.clock, and set our frame rate to 60. Tick at FPS. We just set our Pygame window to be 400 by 400 pixels, and that's a very arbitrary, very random screen size. I just threw a bunch of random numbers out there. But we're working with screen dimensions here, so we need some more information about it. And we can do that by simply calling pygame.display.info. And we can store that in a variable display info. Display info. We can even go ahead and print out display info. Print display info. And if we run our code in the terminal, you can see all sorts of information about our Pygame window. Specifically, what we'll be working with is current width and current height. You can see that it correctly displays 400 by 400, which is what we set our window mode to. We can access this property of display info by calling display info dot current height and display info dot current width. And we can store that in display width and display height. Everyone's computer screen is different. We all have different aspect ratios. A very common one would be 1920 by, I believe, 1080. That's a very common aspect ratio. If we see my display settings, we can see that my resolution is 2240 by 1400, but there's many other aspect ratios. You can calculate your device's aspect ratio by dividing display width over display height. Aspect ratio equals display width over display height. Now that we have this information, then we can set up our Pygame window. Now that we have our aspect ratio, what we essentially want to do is make our Pygame window a miniature version of our computer screen. Make it have the same width to height ratio. And we can do that in window mode. Instead of setting it to a fixed value of 400 by 400, we can set it to aspect ratio times display height and display height. And if we run our code, something's wrong. I switched these two up. This should be current W for width and H for height. And when we run, we can see that our Pygame window is indeed a miniature version of our computer screen. It has the same ratio of width to height. Just so that you can distinguish between the different surfaces we'll be rendering onto our Pygame window, we're going to make the background green. The Pikachus have a red background, and we'll also have an additional blue rectangle. For the green, all we have to say is window dot fill with green RGB 0, let's say 150 and 0. And instead of window, let's just rename window to green, so we know which surface we're talking about. To display our Pikachu image, we can call pygame.image.load. The name of our image is pikachu.png. Let's name this Pikachu image. We can also load in our pixel grid, and again convert alpha. Displaying Pikachu onto the green surface is as simple as saying green.lit Pikachu image at, let's choose 50, coordinates 50, 50. And when we run our program, we have Pikachu displayed at 50, 50, and it does not move or change shape in any form when the window is resized. Remember that we'll also be making a blue surface. We can just call that blue. The dimensions of our blue rectangle, the initial dimensions, will be aspect ratio 250 by 250. And we can make our blue rectangle blue equals pygame.surface. This blue rectangle is very important. When you have a game, you're going to want to render all of your game elements onto this blue rectangle, because we will then be resizing it to the size of the Pygame window, which resizes all the game elements on the blue rectangle by the same scale. So we want to display all game elements onto the surface, the blue, resize this blue rectangle to the size of the Pygame window, which is the green, and then all elements rendered onto the blue are resized by the same scale. Let's go ahead and fill our blue surface with a blue color. We can say blue.fill. And if we run, nothing will happen because we need to display blue onto green. Green.lit blue. And we have our blue rectangle. When I say that all elements on the blue will be resized by the same scale, when the blue is resized, we can demonstrate this by first rendering on our Pikachu and our pixel grid to the blue surface. .lit Pikachu image pixel grid blue.lit. 100 is too small. Let's try 300. So we have our pixel grid and Pikachu rendered onto the blue. Think of the blue, the Pikachu, and the pixel grid all as one single entity. When you resize the blue, everything within will be resized to the same scale. So let's go ahead and resize the blue by using pygame.transform.scale equals pygame.transform.scale blue to the size of green. Instead of directly displaying blue, we're going to display a scaled blue, scaled blue. And since we resized the blue rectangle to the dimensions of the green rectangle, everything on the blue rectangle is resized by the same scale. Note that the position of the Pikachu and the grid also changes. A few things to note here, but first I'm going to set the bottom right corner of the blue to the position of our mouse cursor on the Pygame window. So scaled blue equals pygame.transform.scale of blue to the position of our mouse. And we can really compare. First, notice the difference between the Pikachu on the blue and the Pikachu on the green when I resize the Pygame window. Also recall how the pixel grid was a 10 by 10 image. So if we render the pixel grid onto green, which we can actually do, green dot lit, not Pikachu image, pixel grid at any position, let's say 200, 100, 300. Then when we run, each black and white box is 1 pixel of the Pygame window, and it doesn't get any larger or smaller when we resize the screen. On the blue rectangle, we can see it gets much, much larger, and that's because this blue rectangle has its internal resolution. Think of a coordinate on this blue rectangle as not the coordinates on your Pygame window, but as a grid position relative to the top left corner of your blue rectangle, with each grid position having the size of 1 box on that pixel grid. Of course, those also change size when you resize the blue rectangle. And if you still don't understand what I mean by a grid, here's another demonstration. Here I declare the blue rectangle as a surface with dimensions of 10, 10, which is the same as the dimensions of our pixel grid. I render the pixel grid on the blue rectangle at coordinates 0, 0. So the pixel grid should fit perfectly on the blue rectangle. And the blue rectangle is scaled from 0, 0 to the position of my mouse. The 10 by 10 pixel grid image is blended onto a 10 by 10 surface, and we're resizing the surface. Notice how 1 pixel on the surface is much larger than 1 pixel on the actual Pygame window. That's why I like to think of it more like a grid. The Pygame window is more fine-grained, while the resized surface is not. I can even move the position at which the pixel grid is blended at, let's say 1, 1. And notice how much it moves on the blue rectangle when I move it to the position 1, 1. I can even draw a 1 by 1 rectangle at the top left corner of the blue rectangle. At top left, 0, 0, a width of 1, and a height of 1. And if we run, that is a 1 by 1 space on the blue rectangle. Again, the screen is much more fine-grained than the blue rectangle since we're resizing the blue rectangle by so much. One more thing to note, to be very careful about when doing this, is mouse position. Since you've scaled everything up, the coordinate of your mouse on the position of your Pygame window, which is what pygame.mouse.getPose does, is not going to appear the same as the position on your resize display, the blue. And if you're confused, we can demonstrate this. Then we can draw a circle at where our mouse is. Say pygame.center at our mouse screen position, and a radius of 5. And if we run our code, we can see that some pretty funny things happen. This happens because the grid position on the blue is not the same as the pixel position of your mouse cursor on the Pygame window. And there's a very simple fix to this. All we have to do is multiply the mouse position by a certain scale. Display coordinates, or rather, mouse grid coordinates equals of mouse screen position. We need to get our current window width and height. We can store that in window width, window height equals pygame.display.get window size. We need to find the ratio of the blue to the original window width when we ran our Pygame program. So we can say screen, I spelled that right, yes. Display ratio x equals blue dot get width, the current width, over the original window width, width, not height. I keep mixing those up. And screen display ratio y equals blue.getHeight, the current height of the blue rectangle, over the window height, the original window height when we loaded in our Pygame window. And we can use these ratios to display our circle at the correct grid position on our blue rectangle. What we need to do is multiply the mouse grid coordinates by the x and y ratio that we calculated above here individually. So mouse display, or rather mouse grid coordinates of index 0, multiply that by screen display ratio x, and mouse grid coordinates of index 1, the y, multiply that by screen display ratio y. And instead of displaying the circle at screen position, we're going to display it at the grid position on the blue rectangle, mouse grid coordinates. And when we run, it is rendered at the correct spot on the blue. All code and assets used in this video are in my GitHub, which will be linked down in the description below. If you found this video enjoyable, or if you found it useful in any way, please consider subscribing and leaving a like, and I'll see you guys in the next tutorial.